Hello everybody, you're very welcome to this episode of Programming and Algorithms. In this episode we're going to just look at Google search, or we're going to look at one part of Google search at least. When Google gets to a page, it does an analysis of the page, it looks at what words are on the page, and it makes determinations as to how relevant it might be to your search. So if I search for the phrase banana, how Google will know a particular web page is about bananas is if the word banana appears a lot on the page. So we're just going to look at how you might look at through a file and see how frequently words occur in it and do an analysis of the files. So here's our pick. This is the droids we're looking for. So let's look at how Google search works. There's two bits to it really. We mentioned it before that Google sends what are computer programs out on the web. They're called spiders, and they crawl from link to link, and they find web pages and take copies of those files or web pages. And then it does the bit we're talking about today, which is to scan those pages, identify what the frequently occurring words or phrases in the page are, and determine, and that helps to determine how important that page is for a particular search. So if I have a web page that has the word banana 300 times in it, and a web page that has the word banana in it once, I know the page that has banana 300 times in it is probably more relevant if I'm searching about bananas than the page that only has the word banana in it once. So we're going to look at that. We will recall though as well, just to mention it, that Google does also rank pages or decide what order the search returns in on the basis of if a page is well known. And if a page is well known, how we know a page is well known is if other well known pages point to it. So if government websites or newspaper sites point to a particular page, and let's look at the big yellow page there. So a lot of pages point to that page, and it also points to very good quality pages, then we know that that is also a quality page. So it's kind of a friend approach, or a certificate of trust almost. If reputable sites are pointing to me, that means chances are that I'm reputable also. So what Google does is it establishes a few reputable sites like Yahoo or irishtimes.ie or independent.ie, and if they are pointing to a site, then chances are that that's a good site. So that's a second half of Google that we search that we won't really consider today. Where we're going to look at is just how to analyze files. So let's look at how to, first we do the basics, which is how to handle a string, a sentence. So let's take our string a long time ago in a galaxy far, far away. That's not a string yet. We have to do this to make it a string. Now we've put it in double quotes or inverted commas, and now it's a string. So if that is our string, let's see what kind of cool stuff Python can do with that. So if I say S is assigned, quote, a long time ago in a galaxy far, far away, once that string has that variable name S, if I say s.split, open bracket, close bracket, what that means is it will split the string into each individual word within the string, and it will put them in an array. So now it's created an array, and the array contains a number of strings. Each string is each word within the original string. So a long time ago in a galaxy far, far away, ... now are separate elements in an array. And it's the normal array. The 0th element is A, the first element is long, second is time, element number 3 is ago, 4 is in, 5 is A, 6 is galaxy, 7 is far, 8 is far, 9 is away, and then 10 is the ellipses or ... So there's 11 elements in that array. If we want to save that array as a new variable, all we just do is say t assigned s.split, and then if we print t is now the variable name that stores those values in it, and we can ask for things about it. We will point out it is interesting. We see the A there, and just underneath is another A, but because the first A is capital A and the second A is lowercase a, there are two kind of different values. With the two words far, far, the first far has a comma after it, so that's a different string from the second one, which doesn't have a comma. We'll also note that ... the ellipses are a kind of thing that we mightn't want to necessarily parse. If we're doing a search in Google, ... is probably not something we'll be searching for. But in some cases, we'd like the two A's to be treated as the same thing, whereas in other cases we wouldn't. And equally with the words far and far. Sometimes we'd like if the program would know that that's the same word, whereas other times we wouldn't, if that makes sense. So if we asked for the length of that string, we'd get 11. As we said, it's 11 different elements of that array. Hey, cool. We're flying in space. It's the Falcon. All right, moving on. So let's take that string again, and now let's do some pre-processing on it. So in a lot of text comprehension and a lot of natural language processing and a lot of linguistical analysis, the first thing the computer does is tidy up the string to make it easier to process. So what I've done for pre-processing here is I've just taken away any confusion. So I've made the A lowercase, I've gotten rid of the comma after the first var, and then I've gotten rid of the ... So if I'm trying to intelligently understand a string, the first thing I do is get rid of some of the things that human beings understand. The computer won't really know what ... means. The computer doesn't need the first letter to be capitalized, and the computer will only be confused with the comma because it'll treat that far as a different word from the other far. So with a lot of, as I said, text processing, even with image processing, you do a little pass first to simplify things, and then you work on the simplified version. So from S, the string, our original one, we've got S2, which is a simplified version of it. And Python has a few neat pre-processing features that we'll have a look at, just two that I think are really cool. One of them is, if I have the string S3, which is Darth Vader, Obi-Wan never told you what happened to your father, Luke. He told me enough, he told me you killed him. Darth Vader, no, I am your father. This is one of the most misquoted lines in movie history. Everybody says, no, Luke, I am your father, but Darth Vader doesn't say the word Luke there. He just says, no, I am your father. He doesn't say, Luke, I am your father. That's like Play It Again, Sam, and all those other misquoted ones. So if I have string 3 that's that quote, then if I say S3.lower, what that means is change everything into lowercase. Straight away, as you can see, the name Darth Vader and Luke and the start of each sentence now is lowercase Obi-Wan. They're all lowercase, which is a really quick way of getting rid of all the capitalization. If we go back to original string again, and we have it as is, we like the Darth Vader, but it's too long, so we want to change it to Darth just. All we need to do is do S3, our string, dot replace, and we replace the words Darth Vader with the word Darth. Obviously there are other non-Star Wars examples you can use this on as well, but this is a handy way of thinking about it. So now we can see everywhere where it said Darth Vader, it's been changed to Darth. So that's a really quick way of replacing a particular string. A lot of newspapers do this automatedly. So let's say when they see the word the Queen in sentences, a lot of British newspapers run a replace that automatically changes that to Queen Elizabeth II. And then that comes up with quite funny results when you look at articles about queen bees and things like that. So a lot of this replacing is done. So there are two nice pre-processing things. One is lower to put everything in lowercase, and two is replace to replace values within a string. Wow, he is his father, okay. Now let's have our process string. So our process string hasn't got a capital A, it doesn't have a comma after the var, and it doesn't have the ... If we split that now, a long time ago in a galaxy far, far away, the word A is the same A in both instances of it, and far are the same instances as well. So Python does provide us a way of identifying repeated values within an array. And it's from, I don't know if you guys remember set theory from school, intersection and union and all that. So you'd have the circle thing, A, and there'd be a number of values stored in A, and then a number of values stored in B, and any of them that were in common was A intersection B. And if everything in both was A union B. A set has one specific rule that's very important. A set only ever has one instance of a particular value. So it's a key rule that there are no repeated elements in a set. And Python provides a function with that name set in it. So if I have T2, which is a long time ago in a galaxy far, far away, if I say U2 is the set of T2, it removes any duplication in the string, in the array rather. So then far is only there once, and A is only there once. We'll remember that there was 11 elements of the first array. We got rid of the dot, 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 which brought it down to 10. And now, because far is duplicated and A is duplicated, we've gotten it down to 8. And there's Kylo Ren. We'll have to see his lightsaber with the cross hilt. Cool. Okay. So let's look at our first program to do a bit of pre-processing. A handy way and the most common way to write a program if we want to do a bit of pre-processing is first declare an array of characters that we want that are acceptable within our string. So as you can see in this case, we've declared an array, we've called it keep. And we've said the lowercase letters A, B, C, D, F, G, H, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z, plus space, plus dash or minus sign, and plus single quote are all acceptable characters. So we wanted to write a program that said, everything else goes except these. And if we had that program, then our string a long time ago in a galaxy far, far away, the dot, dot, dot would go, and the comma after the first far would go, because none of them are acceptable. So let's have a look at some code. We're going to declare a method or module called normalize, and we're going to declare an empty string called result. And we're going to go through each word in the string that's passed into normalize, and we're going to lowercase it. So we go for x in s.lower, and x is each word within it. If x, or each letter, I beg your pardon, if each letter is in the array keep, so if it's in the list of potential values we're allowing, then we add that new letter x into the result string, which starts off as blank, then the first letter is added in, the second letter, the third letter. Else we don't do anything. So if the next character we read in is not in the keep set, then we just don't add it onto the result string. So think about that for a minute. We're getting in characters, let's say it's ABC exclamation mark. For x in that string, ABC exclamation mark, x will first be A, then B, then C, then exclamation mark. If x is in keep, so the first value is A in the grid keep? Yes, it is, so we'll keep that one. So that means result, which is a blank string, gets A added onto it. So result is now A. The next time around, it's B. Is B in keep? Yes, it is, so we add B onto A, so we've got A, B now. Then we get to C. Is C in keep? Yes, it is. Then we get to exclamation mark. Exclamation mark is not in keep. Because it's not in the list we've declared of acceptable values, then we won't add exclamation mark on, so the result that returns back is just ABC. And then if we want to call that, we could call it by saying, a long time ago in a galaxy far, far away, with commas and dot, dot, dot. So if we call this method or module that we've created called normalize, and pass in that quote into it, and return the result back as new quote, if we print out the old quote and the new quote, what we'll get is a long time ago in a galaxy far, far away, with commas, with dot, dot, dot. And when we do our normalize, the A will be lowercased. A long time ago in a galaxy, the first far, the comma will be gotten rid of, because the comma is not one of the keep characters, so that gets thrown out. And dot, dot, dot gets thrown out as well. We keep the spaces as well, of course. Just to go back, we're also lowercasing the complete string, so we're going for x in s.lower, so that means whatever string is passed in, we put everything in lowercase in the string straight away, and then with those lowercase ones, any character that's not in keep, we just get rid of it. So that's how we end up with what's called a pre-processed string, or it's tidied up, so then it's much handier to be dealing with, because sometimes uppercase and lowercase they count as different words. Whereas when we're counting our frequency of words, it's as handy just to have everything in lowercase, and then every time we see the small letter A, we know that's an occurrence. Because otherwise we might think capital A and small a are two different words, and that's just silly. And it was the same if we're searching for bananas. If the word banana is at the start of the word, then it'll be a big B, whereas the word banana is in the middle of a sentence, it'll be a small b. If I asked Google, tell me how many times the word banana appears in a sentence, I don't want it to think capital B banana is different from the string small b banana. So I run a program exactly like this, or string preprocessing, to make everything lowercase. And then I say, okay, how many times the word banana appear? And then it's all the same length. Okay, that's kind of cool. Hey, BB-8. Cool. Okay, so let's say we had the script for the Star Wars movie. This is the first Star Wars movie, A New Hope, and it is on this page. So if you go down to the bottom of the page, you'll have downloaded the Star Wars script. If we have that stored in a text file, that's a .txt. We know from before we can open it for reading by going open the file name, r.read, and now we've opened the script. So we open that text file. Then if we say, tell me the length of that text file, what that'll give us back is, well, it'll give us back 326,359, and that means there's 300,000 plus characters in that script. Characters, individual letters. If we go script.count, open bracket, inverted commas, /n, inverted commas, close bracket, what that means is count how many times new line appears, how many carriage returns there are in this file. In other words, how many lines there are. So each line ends with a new line character. So if I count how many new lines there are, that tells me how many lines there are in this file. As it happens in the Star Wars script. And then if I do split the script into each word, and then tell me the number of words, that is, I find out that there are 33,101 words in the script. So length of the file gives me the number of characters, script count /n gives me the number of lines, and the length of script.split gives me the number of words. So that's a really quick way of getting some stats on a file. And then we can see, look, there's roughly there seems to be roughly 10 characters per word, because there's 33,000 words and 326,000 characters. So it looks like, yeah, you've got a lot of long words in this script. There's 8,000 lines and 33,000 words, so that means on average that would be 4 words per line, I guess, which is not a lot, but movie scripts often it's just 1 word per line, as I'm sure you know, and if you open up the file you can see a lot of the lines are very short. So let's look at a new type in Python called the dictionary type, and this will help us explore these files in a lot more detail. So Python has a built-in type called dictionary, and it's exactly like an array, except check this out, this is wild. Instead of being indexed by a number, you can index this new type of array or dictionary by any type you like. So let's look at an example. If we remember our array, a 7-element array there, the 0th element, 1st, 2nd, 3rd, 4th, 5th, and 6th element. The first element, or 0th, has 31 in it, then 41, 56, 26, 53, 59, and 66. So if I do array, open square bracket, 2, close square bracket, it'll return the value 59 to me. Now, instead of indexing the array by numbers, we can index this dictionary type by letters in this case. So if I do dictionary, open square bracket, C, close square bracket, it's going to return the number 59, because 59 is the 6th element. the fth element is 59 as well, and the gth element is 66. So it's not that the numbers on the bottom represent an index n, it's that those letters now represent an index n. So tell me what the bth element is. The b element of this dictionary is 41. Wild. I think it's a cool approach. You can use letters, you can use strings, you can use booleans, you can use whatever the heck you like to index this dictionary type. And you can store whatever values in the dictionary you like as well. So if I can declare a dictionary type by using the curly braces. And if I say declare a variable called title, and I say title has the following values in it. The first element will be indexed by the word the, and will store the number 1 in it. The second element will be indexed by the word force and store the number 2 in it, and the third element will be indexed by the word awakens and store the number 3 in it. So if I do title open square bracket force close square bracket, it'll return the number 2. If I do title square bracket 2 close square bracket, it'll give me an error because there's no such thing as the 2th element, the second element of this at all. The indexing is by the words the, force, and awakens, which is fun. And then if I ask it, tell me what the keys are or the indexes are, by saying title.keys, it says the index names are the force awakens. They're not the values now, they're how you index the values. And if I want to add in a new value, I could say add in a new value Star Wars in quotes and put a value in Star Wars of 0. Now as it happens, it's going to put the word Star Wars at the start. So then we have Star Wars, The Force Awakens, 0, 1, 2, 3. It can be any values you like, really. The numbers don't matter there. It's not like it's putting them in order on the basis of numbers there. So let's write out a program to count the frequency of each word in a string using this dictionary type. So here we go. Our program is called freq_dic, so the frequency using a dictionary. And the first thing we do is do a little pre-processing. So let's add in a picture here. So the first thing is a bit of pre-processing, and our pre-processing, there's 2 bits to it. The first thing we do is normalize the string. So we remember what that does. If it's a long time ago in a galaxy far, far away, it makes the first A lowercase. It gets the comma off the far and gets ... away. So we've put everything in lowercase, and we've gotten rid of punctuation marks that we're afraid the computer won't recognize. Then the next thing we've done is split that string now into individual pieces. So now it's in an array of individual words, and that array is called words. So now we're going to declare an empty dictionary by going dic is assigned open curly braces, close curly braces. And now what we're going to do is have an index called word index, and we're going to go through each word in the string. And if that word is all, let's say this is the first time we've seen this word ever, that's down at the else bit, then we're going to add 1 to the count in that element of the dictionary. So let's say I find the word a. The first time I find the word a, I'm going to create a dictionary entry with the word a in it, and I'm going to assign that to the value 1. Now the next time I find the word a in the dictionary, word index will be in dic. So then whatever value a has, it is 1 at the moment, it's going to be a plus 1, so it's going to be 2. So this is going to count how many times each word appears in the dictionary. So if I pass in the string, a long time ago in a galaxy far, far away, it'll first pre-process the string by taking away all the capitals and getting rid of all the punctuation marks. Then it will create a dictionary called dict, add in each word into the dictionary as it's going along, and if it sees that word again, it will add 1 onto the values being stored beside that word. So as we can see, the only 2 occurrences of words that appear more than once is a and far, because far, far and a long time ago in a galaxy far, far away. All the other words have appeared once. Now we can see how Google is going to start doing its processing. We can see once we know how frequently a word is occurring in a file or a web page, then we have a good clue as to how relevant it is to our particular search. If I have a web page called, if I search for the word Lucasade, and I go into a web page and it's got 100 instances of the word Lucozade, I know this web page is about Lucozade. Whereas if it's got 100 instances of the word Sprite, then I know it's about Sprite. So it's just to know how frequently a word is occurring, and that'll be a rough guess as to how relevant that page is to our particular search. The only problem with the dictionary type is, which is a pain, is because it's indexed by words, we can't necessarily guarantee the order it goes in. It doesn't index in alphabetical order. It doesn't index by the value stored in it. It's quite loose the way it stores the values. So we have to use a trick to order it. If we want to order the values, what we need to do is we do the following. We create a new array called dictionary array, and then for each element in the dictionary, we insert that pair into the array. So we take the dictionary and put it in an array, and then the array now has all the values that the dictionary has. With the array, we can sort it. With the array, we can order things. With the array, we can pick out the top 20 words by just asking what values have the numbers in. If we took our string a long time ago in a galaxy far, far away and just converted that dictionary into an array and then said, give me the top 2 values, it would be A and far, because it's 2 values. So now I'm going to say something shocking, which is over to you. Now this is different from before because this is really over to you. Because on this page as well, down at the bottom, there's a fully working program that will take in a file, that will count the number of words, lines, and characters in it, and will also print out the top 20 words within that file. I've explained the basic mechanics of how it's going to work to you, but I need you now to take over this, read the code, understand it, and understand exactly how it is getting the 20 words. It's doing exactly what we've done though. It's doing an analysis using a dictionary, and then from the dictionary it's creating an array, and then it's saying, give me the top 20 elements in the array. So over to you. Thanks very much. We'll see you on the next episode.